ask you to change. Anyway, and that's all for the exam. Um, you can find me on my email arnaldo.spalvieri@polimi.it, and you can find me also on my students time, which is, I don't know, maybe on Tuesday from 9:30 to 11:30. Anyway, it is on the official website of Polimi. So please write an email to me if you want to come to students' time. It is better that you first drop an email and then I answer you. If you cannot come during the time window of the students' time, we will find another time window. No problem. Okay. If you have questions, ask during the class. Stop me, raise your hand, and say, Professor, I don't understand this and that. Okay? It is better doing so than remaining without understanding what I'm saying and what I'm writing. Okay? So stop me. Uh, Last year we also tried, and it has been quite a success, a form of, let's say, flipped classroom. That is, in the last 2 or 3 classes, I asked who wants to make the teacher for one time, for 1 hour, and I had 3 students that said, okay, professor, I'll try to be the teacher for 1 hour. And so I gave, sorry, he was expected to call at 10 o'clock. Hello? Buongiorno, sono Spalvieri, io sono in aula adesso, però sono a lezione. Ci possiamo sentire alle 11:30? Va bene? La chiamo, la chiamo io alle 11:30, grazie. I'm very sorry, now I put it in, well, there is audio, silent mode, okay. So teacher for one day has been quite a good experience, especially for me, because at the point I was sitting, looking to the student that was giving the lesson. But anyway, we can try to do this also this time, 1 or 2 students, no more. It is a good experience for the student, it's also for the class, it's also for me. It works like this. I give to the student all the material. I have some written material like this. Of course, you have the book, which is the yellow book by Barry Lears Messers, with the same book as in the official program of the course. It is written, the complete title is in the official program of the course, okay? Barry Lears Messers with digital communication, something like this. Frankly speaking, I cannot suggest to study on that book because it is really hard. Really hard. You can buy that book or have some photocopies or what you want, and you can use it, let's say, as a reference. If it happens that you don't understand something during the lesson, in my material, you can go more in depth thanks to that book. But it is not easy. It is quite hard. Okay? So I prepare the material, I come to the class with the material, I follow the material, and then I put the material on BIP. Okay, you will have everything on the BIP website. Usually I put the material on BIP after the lesson. because what happens is that during the lesson I always find errors in my material. I correct them, or you make questions, and so I have to improve in some way. If you don't like this, I can try to put the material in advance before the lesson. But anyway, what happens then is that I can change it. That is, I put something and then I overwrite it by uploading some new material in place of the old one. So I don't know what is the best. If you want to come to the lesson having already something in your hands,
Yes.
you prefer?
Yes. Yes.
Do you prefer having something in your hands when good morning, when the lesson starts? Well, if you prefer this, I can upload the material in advance before the lesson. But you are advised, you know, that after the lesson or after a group of lessons, I can upload a new version. Of course, with minor changes, only minor changes, small correction, but anyway, this is possible. I can upload something new after the lesson. Okay, so this afternoon I'm going to upload the first part, which is called the minimum mean square error method with application to linear prediction. So what I said about the book, I said about the material, I said about the exam and about the flipper class. I give the material to the student. The student studies because it is his job. Student studies. Studies the material, and then after the study, he comes, and before the lesson, after the study and before the lesson, he comes to me and makes question, and we work a little bit together to put the lesson in the right framework, and then he goes, okay, in front of the class. I'm sitting there and I make questions. Okay.
Will you give us the chapters of the book we will be using?
Yes, I give you my material and the chapter of the book, of course. The title of the lesson and all what you have to say. That is what the phrase, the line, the big picture, let's say. The material is similar to the material that Professor Magarini already uploaded. That are slides. Well, in my case, there is something more, especially for the first topic, which is the minimum mean square error, because there is nothing like this on the book. There is something that is close to what I'm going to do, but it is scattered here and there in the book. So I need to make something more substantial than simply slides. So the form is like this, you see? We call in Italian, we call this a dispense, which is something in between the slides and the book. In between, okay? You see? There is not a picture, only equations, a lot of equations. The number of a picture, here is it, a picture. However, this is picture number 11, and this is equation number 140. Okay, you see? Of course, you do not need to remember all these equations. It is absolutely impossible to remember all the equations that are written here. I have written everything because I don't remember the equations. Okay, so I need to write them and to bring them with me during the lesson, just because I don't remember them. Okay? But when I see the equation, I know what it means. Of course, I've written it. And the same for you. You don't need to remember the equation, but you need to know the meaning. Okay? All right? So the material, the exam. Questions?
It is already online and it's the one that is digital communication.
Sorry, can you repeat?
The BIP is already online and it's the one that is digital communication.
Yes. Or yes, no, I don't know. I must go to the BIP. Maybe there is a DC2, a digital communication 2 topic on the BIP.
Only digital communication.
Or is it only digital communication? Only digital communication. So you don't have digital communication 1.
Yes,
You
we
have
have
No, we
digital
do.
communication
One.
1 and
And
digital
that-
communication.
communication 2 that are below digital communication. So I will open the digital communication 2 page and I will put my material on that page. Anyway, I will do this in the afternoon. Okay, so on Monday we can comment about also about this. Okay, in the tomorrow try to open that page and see if you can download the material. If there is no problem, we will go on with that on that way. Tomorrow, which is the lab day, there will be no lab because Maurizio Magarini said, I want to do a pre-exam. I don't know when, at the beginning, when is the pre-exam? On Saturday. So let's leave some space, some room to the students for studying 3 hours. We cannot do more than this. We cannot do more. Also, what happened this year is that the time window for all the first semester is very short because before Christmas we close the semester. So it is really very, very compressed. And there is no time, basically, no more time than this for studying. I don't know the reason why they said the dean, basically the dean, decided to do this. But anyway. Okay.
One thing about not remembering the equations. We don't have to remember.
So,
the equation.
well, it depends on the question. If I ask you the Pythagorean theorem, you must remember it. Okay?
But,
A to the square plus b to the square equal to c to the square, you must remember it.
but how is the structure of the x and the x that we derive the equation or
Well, what I mean is that here, only in this first part, you have 144 equations. You don't need to remember all the 144, but you need to study and to understand which are the 10 basic equations. There are 10 equations, or 11, or 9, or something like this, that are among the 140. And you must understand which are the 10 important equations. For instance, in this E1, you have C equal to B log 2 of 1 plus SNR. You see, I remember it. I say that I don't remember equations. And actually, I don't remember all the equations. But there are some equations that I remember and that you should remember too. For instance, the channel capacity formula. There are certain equations that are more important than others. And when you study, you must, let's say, select what is important and what is less important. Questions? No questions? Okay, let's go. The minimum mean square error method. The minimum mean square error method is very basics. in many forms of engineering. Basically, it is inherently related to the theory of linear systems. Linear systems, we mean linear systems, we mean filters. And basically the question is the following. By the minimum mean square error method, you answer to the following question. I observe a signal coming from the environment, for instance, at the receive side, I observe a signal. I have to filter it in such a way that the output of the filter is close to a desired signal. For instance, you find this problem, for instance, in equalization. You receive a signal from the radio channel, and the radio channel is affected by multiples or linear distortion. You have to recover at the receive side the linear distortion, and after the filter that recovers the linear distortion, you want to find the transmitted sequence. So the desired signal is the transmitted sequence, and you want to filter the incoming signal in such a way that the output of the filter is as close as possible to the desired sequence, that is the transmitted data sequence. As close as possible in the mean square error sense. That is, compute the error between what you get and what you want, raise it to the square, and make the expectation, the average. This is the figure of merit that you want to minimize by the minimum mean square error method. The equalization is only an example. We will extensively use this method for linear prediction. What is linear prediction? Linear prediction is a very basic activity of the human being, but also of the engineer. For instance, I can ask you which will be the temperature here tomorrow. This is the answering to this question is an instance of prediction. You look outside, you see the sky, you know that it is November, 11 in the morning, okay, and you say tomorrow at 11 in the morning it will be around 14 Celsius. This is prediction. It can be 15, 13. You make your best guess and say 14. Linear prediction means that your prediction is obtained by a linear processing on the observables. You have a set of observables quantity, for instance, exactly the sky, all these observables are numbers, of course, in our context. You have a set of observables, and you make prediction by weighting and adding the observables, the measurements, okay? That is by a linear combination of the measurements. The activity is that of designing the weight. How large is the weight of the first measurement? How large is the weight of the second measurement? How large is the weight of the third measurement? I have to design all this weight and then add the result of the multiplications between the measurements and the weight. This basically is linear prediction. The activity looks like this. Suppose a very basic case. Suppose that you observe the time evolution of a waveform, like this. And we will make the discrete time version of linear prediction. So actually what you observe are the samples, but as you know from the sampling theorem, if the samples are taken at the frequency which is greater than 2 times the bandwidth of the signal, then observing the same process, like to say you're observing the continuous time wave. Anyway, now the point is here. What about the next sample? The one that I don't see now. Well, looking to the past, you can predict, of course, with error, you can predict the future. And in this case, I could say this, or this, or this. Of course, the method is such that you will say, this is the next sample, not this one, not this one. Why? Why not? Why not? Well, from the picture it seems obvious. It seems obvious. But now you're asked to give an answer which is a scientific answer. So you must motivate this with formulas. Okay? You must have a formula that, given this, and this, puts them together, makes weighting, adds, and find the result. Why not this? Why not this? Because of the bandwidth of the signal. Okay, you see, this is a band limited signal, which means that it cannot have two sudden changes. It cannot pass from a value to a far value in only one time instant. Because elsewhere you will face a signal like this. This is a wideband signal. Please, the next sample. Okay, it can be this, or this, or it can also be this one. Why? Because you see the difference? That is smooth. The one here has a lot of up and down edges in the same time window. Okay. So basically, in this case, you apply a narrow band filter to the past to predict the future. In this case, you cannot apply a narrow band filter. Because, why? Because the process is inherently wideband. And so it becomes more difficult to predict it. Of course, the point is that this time is too long compared to the coherence time of the process. So, if you have sampling like this, you see you are losing a lot. The same happens also with this process. If I ask you to say what will happen after a long time, you are here, and I ask you, please predict the signal here. Yes, it is true, the signal is narrowband. So the coherence time of the signal is large. It remains equal to itself for a long time. But this time is really too long. And so, what will happen? Who knows? It can happen something like this, which is likely to happen, because it is anyway smooth, but also this is possible. And also this. How to predict? Well, you can try, but the prediction error will be large. Okay? So it is a matter of bandwidth of the signal, bandwidth of the prediction filter, and of course time lag. Okay, questions? So given this